Hey, Mr. Miedrich, it's good to see you again. A question for you. Is there like any food that like you just can't do?
There, gauging by my size, probably the answer would be no, but there are a few that are on my hate list. Turnips would be near the top. Pretty much anything in the vegetable family. Again, not a huge surprise here. How about you?
I hate mushy food. Anything mushy, especially like mushy vegetables. I like vegetables as long as they're raw, but you mushy, do not like mushy.
Yeah, I hear you.
Oh, this doesn't work for me. I mean, I like oatmeal or something like that, but like mushy vegetables, it's just when you boiled vegetables, it's death. It's hard. Okay, hey, guys, we're going to continue our discussion of dimensional analysis. And today we're going to do kind of more difficult problems. We like to call them multi-dimensional problems. And what we've got is we've just got 3 key tricks that you have to worry about. So the 3 key tricks when dealing with, let's call it multi-dimensional problems are, number 1, so number 1, do 1 dimension at a time. Again, this may not make complete sense when you're writing this down, but it will when we do examples. Number 2, when units are on the bottom, not in the bottom, that's an O, on the bottom, cancel up. And when dealing with square or cubic units, you must write each one out and cancel twice or 3 times. Square twice and cubic 3 times. So the only way to learn this, Mr. Dimitrich, is probably to do what?
You got to do examples, and I think it'll make sense.
So our first example is if you're going 8.5 kilometers per hour, we want to go to meters per second. Now let me say this, guys, really, really, really important. That little line there, I call a slashy. There are no slashies allowed in conversions, never slashies. Mr. Demetrius, where do slashies come from when they're doing them? They are from where?
Well, whenever you're doing your table, the slashy is a divide number. So that slashy means you put whatever's below it underneath in the table.
So you don't say 8.5 km/HR, you write 8.5 km over 1 hour. You see, that slashy means this. Write it this way. Do not write it as a slashy. So no slashies. They're from the devil.
Yep.
Okay. Now, the rule says that we wrote down a minute ago, you do 1 dimension at a time. So I need to convert kilometers into meters and then hours into seconds. And you do them 1 at a time. Let's do the kilometers. Kilometers on top. We're going to go from kilometers to meters. Now, this is a conversion that's actually built into the metric system, right? So I'm going to put kilometers on the bottom. Notice what I'm doing is I'm just putting the unit on the bottom and meter on the top. I know this conversion. So I do kilometers to meters. And, here's a rule I like when we do the metric to metric or whatever, is you put the 1 next to the bigger unit, right? So the biggest unit is a kilometer. So he's a 1. So then how many meters are in a kilometer? Mr. Dimitrich, I bet you know this.
That's 1,000.
There's 1,000. So now the kilometers cancel. But I'm not just interested in converting the kilometers into meters. I want to convert the hours into seconds. And let's do another fraction. Now here, guys, and the conversion table here does not have hours to seconds. We're making an assumption that you know some of these conversions. Now, notice that the hour is on the bottom. So if you looked at the rule number 2, it said if the unit's on the bottom, you cancel up, right? So the hour's on the bottom. So what do I do up here, Mr. Dimitrich? What unit do I write?
You got to put an hour on the top.
I got to put an hour. On the bottom, now do you know, maybe you do, but I bet most students don't know how many seconds are an hour, but they do something else. What else do you know? You know how many what?
You know how many minutes there are in an hour.
So I can do minutes.
So we can do this
right? And which is bigger, an hour or a minute? Well, it's an hour.
An hour is bigger.
There are 60 minutes in an hour, so my hours cancel. But now I have like meters per minute. I don't want meters per minute. I want meters per second. So I add another fraction. And now since the minutes on the bottom, and I want the minutes to cancel, where do I put minutes in this last fraction?
Now minutes go on the top.
And I can put seconds, abbreviated S, on the bottom. The minute's the bigger unit. He gets a 1, and this is 60 seconds. Now, again, this goes back to the last video. numbers on the top, multiply, numbers on the bottom, divide. So I'm going to take 8.5 times 1,000 divided by 60 divided by 60. I know it sounds weird to pay divide. You say they're multiplied. No, because it's, just trust me, that's how it works. I get 2.3611. And this is only two significant digits. These are all definitions. So that's going to be 2.4 meters. Now I might write this with the slashy because that's just the final answer. This next one, we're going to convert 0.49 pounds per liter into grams per milliliter. All right, Mr. Dimitrich, first thing we got to do is how do we rewrite the 0.49 thing?
You have to set it up just like we did every time with the train tracks. And remember, slashes we can't write together. So slashes mean divide. So that number that's the units on the bottom is going to be set up that way.
So we got 0.49 pounds in a liter, and I have to do the pounds to the grams and the liters to the milliliters. Now pounds to liters, conversion tables, we know this. Now pounds is on top, so I'm going to put pounds on the bottom and grams on the top. We do know this conversion. So again, what's that conversion from the table, Mr. Dimitrich?
Well, I'm looking at it right here, and it says 1 pound is equal to 400 and my glasses are not on right now, 53.6 grams, I believe.
Yep. So the pounds cancel, and now I've got grams, so I'm happy. But now I need to get from liters to milliliters. Now, liters is on the bottom, right? So if you've got a unit on the bottom, you cancel up. So the liters goes on the top, and I do milliliters on the bottom. Now, that conversion may not be on our conversion table, but milli, which is bigger, a liter or a milliliter?
Liter is definitely bigger.
So he gets a 1.
So we put 1 next to it.
And then we have 1,000 milliliters. There's 1,000 millis in a hole. And now I get my trusty calculator out, and I got numbers on the top and the bottom. 0.49 times 4, oops, type right, 453.6 divided by 1,000. And I get this to be 0.222264, and that's grams per milliliter. I need to, of course, round that to 2 sig figs, so that's 0.22 grams. Our next example was 0.054 meters cubed into centimeters cubed. Now this one's tricky because this has cubic units. This is volume, a meter by a meter by a meter to a centimeter by a centimeter by a centimeter. But if you looked at the last rule, look at your notes, you'll notice that you have to write them separately. So I'm going to write 0.054, and I'm going to write meter, 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 because that's what meter cubed means, right? Over 1. Now, you now have to do this, the conversion from meters to centimeters 3 times. Meter, meter, meter. All right, so now what you do, Mr. Dimitrich, we're going to cancel out one of the meters, so what do I do on the bottom now?
Well, 1 meter is going to go on the bottom because it needs to cancel, and we have to put centimeters on the top.
And there's 100 centimeters a meter. The meter is the bigger unit, centimeter small, and there's centi means 1/100th, I guess. Now that cancels off one of the meters, but I got to cancel out all 3 meters. So I basically do this 3 times. So the meters, the 3 meters, the meter, meter, meter cancels, and you're left with centimeter, 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 better known as centimeter cubed. So now I'm going to take this 054 number, 0.054 times 100 times 100 times 100, and I come up with 54,000 centimeters. Now I will write the cubed here because that's what a centimeter, centimeter, centimeter is. It wouldn't be wrong to write centimeter, 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 but it's more simplified from a algebraic expression to write centimeter cubed. So when you're faced with, this could be a square, but then it would be like meter, meter. If you square or cubics, you break them apart, and then you have to cancel each one at a time. And our last example, guys, is we're going to do kind of the big monster, horrible, tough question. 15 pounds per foot cubed, and we're going to go to grams per milliliter. So this is a crazy one.
Yeah, you're not going to see problems like this normally. We're giving this example because we always want to make sure that if you can do the hardest example, you can do any example. And this is definitely the hardest example you're going to ever find.
So I'm going to say 15 pounds, but not per foot cube, but per foot.
Times foot.
Foot. And remember, you do one dimension at a time. Let's do the easy dimension, pounds to grams. We've done this like in most of our examples earlier. We can say pound on the bottom, 1 pound is 453.6 grams. So we know that, we're done. That's easy. Now I need to get the feet cubed into milliliters. Now let me give you a hint. To get to feet cubed to milliliters, I can go from feet, let's just worry about the feet. I can go from feet to inches to centimeters to milliliters. So this can be a long process. It's gonna take 2 lines, I'm gonna guess, probably. So to get rid of a foot, I'm gonna go take one of my feet and I wanna get to inches. We know this, right? There's 1 foot is 12 inches. But because it's foot, 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 what do I have to do? I have to do it 3 times. All right, so I've got my foot, foot, foot canceled because I did foot, foot, foot here. Now I've got inch cubed or inch. I can go from inch to centimeter. Now we know that from our table here, right? And we know the inches, it's the 2.54 number. So, but I got to do this 3 times. So I can say inches on the bottom. So I need to put it on top. So inch, centimeter, 1 inch is 2.54 centimeter. And I'm just going to come down here. I do it 2 more times. 1 inch is 2.54 centimeters. And 1 inch is 2.54 centimeters. I've done that 3 times. Now I've got centimeter, centimeter, centimeter on the bottom. And if you look at the table, this is a little confusing, but it says somewhere that a centimeter cubed is equal to a milliliter. Do you see that in the conversion table? And so what we can say is that 1 cm, cm, cm is equal to 1 milliliter. And so that cancels off my cm's. And that's it. Now, calculator is going to be a mess. I've got, I guess, just 2 numbers on the top and a bunch of numbers on the bottom. So I'm going to take 15 times 450, oops, 3.6. You know, I would recommend, guys, that you actually get your calculators out and then you follow along to make sure you get the same answer. Divide by 12, divide by 12, divide by 12. I'm keeping the divide, divide, divide. Divide by 2.54, divide by 2.54, divided by 2.54, and this is just a 1, so that's it. And I come up with 0.24028 or some odd number, dot, 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 and that would be grams per milliliter. Now, that's too many sig figs. This number, just kind of look, as Mr. Dimitrich, you said, just look at the first number, the 15, and this is just going to be, yeah, 0.24 grams per milliliter. And there you have it. So this is the nasty ugly. There is a couple problems that are kind of like this in the worksheets that you're going to have to do. So we're going to see if you can do this. And hopefully you'll see this out. It just, you get feet, 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 centimeter, 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 and you're good to go. Mr. Dimitrich, this is like the end of our first unit. That's pretty awesome. These kids have been like with us, and they're so awesome, aren't they?
Congratulations, students. You've made it through the first unit.
All right, we will see you guys in class.